Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 3. A long solenoid S has length L1 and area of cross-section A, number of turns are N1. A coil C of shorter length L2, number of turns N2, but same area of cross-section is wound over the solenoid S. If current I flows through the coil C, then which of the following represents the flux linked with the solenoid S? So the scenario, it can be visualized as this, that there is a solenoid that is depicted here in blue color, and over that solenoid, one small coil of length L2 is wounded. So we can take it as one another smaller solenoid. But here the number of turns are N1 for the solenoid S and number of turns are N2 for the coil that is depicted in red color. The length of solenoid S is L1 and for the coil it is L2. So this coil is not completely wounded over the solenoid. So now we have to find out the flux linked with the solenoid S. So solenoid is our secondary coil and primary coil is the coil C. So we know flux linked with solenoid is given as phi m is equal to BA cos theta. And we know that since this smaller coil, it also is acting as solenoid, the field lines will be parallel to the area of cross section. So theta will be 0. So theta here will be 0 degree. So it will be BA. So this is the flux linked with the single turn. But we have to find the flux linked with the solenoid that actually are present in L2 length. So for L1 length, number of turns of solenoid, they are N1. So L1 length, it corresponds to N1 turns. We need to find the number of turns in L2 length. So that can be obtained as for single unit length, the number of turns will be N1 by L1. And for L2 length, the number of turns will be N dash and they are equal to N1 upon L1 multiplied by L2. So these are the number of turns in L2 length. So now flux linked total flux, it will be equal to N dash times BA, where B is the magnetic field produced by coil C. So since this coil C is also a solenoid, the magnetic field produced by coil C, it will be equal to mu naught number of turns per unit length, that is small n2 multiplied by current in it. So this is the value of B. And we know this n2 is capital N2, number of total number of turns, divided by the length of the coil C. So it will be mu naught capital N2 I divided by L2. So this is the value of B. So if we use this value of B and N dash, we can find the total flux linked with the solenoid. So phi m, it will be equal to N dash. N dash is N1 upon L1 into L2 multiplied by B. The value of B is mu naught N2 capital I divided by L2 multiplied by A. So A was also there. This L2 gets cancelled out with this L2 and we are left with mu naught N1 N2 A I divided by L1. So this is the final expression for the magnetic flux, that is mu naught N1 N2 AI divided by L1. So let's check what are the options. In option A, it is L1 upon L2 is given, so not correct. Here L2 upon L1 is given, so not correct. In option C, you can see mu naught N1 N2 AI divided by L1. In option D, it is Denominator, we are having L2. So it is not correct. Option C is correct. Thank you. Keep learning, keep practicing, keep excelling.